And then I took forever to do the group thing, so I gotta hurry. Let's back up to the beginning. What happened yesterday? Ellie group gets one first. How do you have it? She's back. Now it's time for a new group, so we gotta meet new people, learn new things. Since yesterday was a test, what were you supposed to turn in that I forgot to mention? Study guide. Every group can have a point. You were supposed to turn in your study guide, did you? About 5.
I did.
About 5. So I am reminding you today, you were supposed to do that study guide. I haven't typed in the 0 yet, but it is definitely coming. It was at the end of the last packet. You only had to do the evens. It was only 14 points since you only had to do the evens. I put it in the 30. It's not going to kill you, but you have so few grades in for the second hour week already. It's definitely not going to help. Okay, so there's that. Now as for our real math, we are super behind on what?
Workshop.
Oh, so far behind. I heard it from 2. 2 get a point. We're super far behind. My date on the last workshop that we never fully finished is 10-2 to 10-6. Can you find your 10-2 to 10-6 math workshop?
Yes.
Okay. Did we already do 5, 6, and 7? And we just need to do 8, 9, and 10. Okay, I just didn't write them down or something. Okay, so today we're going to do just 8, 9, and 10. Tomorrow, because we'll finally have this sheet done, tomorrow we're going to, if you're wanting to be ahead, we're going to do a bunch of them. We're going to do 9 through 13 tomorrow. You just picked up a new one on the way in. We're doing 9 through 13 tomorrow. We've got to book it and like double up and do quite a few math workshops to get back on track. Because if you notice the date on the one you picked up, it's to 10-13. And again, we're in 10-17, people. So we've got to get back on track and get back to the real date workshop. Because I know you say, oh, we'll just skip them. But we can't. Because everybody got to choose. We've got to be all on the same page, doing the same things, doing the same workshop tasks. And I don't want Cassidy to get a stinky sword because Ms. Compton never said some examples. So we're going to make it happen. So again, we're doing 9 through 13 tomorrow if you want to be ahead on that. Okay, moving on. I am not going to be here tomorrow, which means you have a test, which means there's going to be another video. I'm going to go over 9 through 13, and I'm going to finish up the matrix work, the matrix examples or matrix notes we don't go over today.
You should request this Nancy.
Too late. I don't recall. I think it's the same lady. I don't know. No clue. What I'm going to say is that if she writes, so I get on to you, but we talked about her second period is one of my favorite, which you shouldn't have favorite periods, but if I did, you're definitely one of them. So if she writes nice things about you, I'm willing to add points to your group. Like Delaney was so helpful, she was willing to pass out papers. Like if she writes nice comments about a student, I'm willing to add points to your group. But you all know if I get negative comments, I'm taking points away. And even if it's just the class was chatty, I'm going to take points away from everybody. Now, I have left her notes that you're allowed to work together or whatever, but you know what I mean by the class was chatty. It's Jack's, and the whole world was super distracted. And that's not what we need. Because I hate to remind you of this, because I swear it's a long time from now, but eventually I will leave you, and Tylen has to be able to get math done on her own. I will not be here to catch her when she falls.
So we'll just have like a stub.
Just tomorrow is just a step, yeah.
I'm talking about like weird.
I don't know. That's a long way away. Oh. Okay, let's go to number 8. You think I picked those things? I don't. What was I going to say? Oh, this one's an easy one. What do we need to do first? There are a lot of points available today, by the way, and you and your new group need to work on it. Before we do, yes, any problem we think GCF, but there's no GCF on this one. So what are we supposed to do first on this one? Can we not just combine like terms? Can we get a point? So x squared plus 6x plus 8, and I don't have a lot of room in my paper, so I would love someone to go all the way to the answers. What are my 2 factors? Gilberto, get a point? 4 plus 2 is 6. 4 times 2 is 8. So my factors are x plus 4, x plus 2. Perfect. Are there any questions on number 8? Number 9 actually is a GCF problem. Is there a GCF? Say it again, Ellie.
3PQ.
It is 3PQ. So if we pull out a 3PQ, and you can have a point for that, we would be left with...
P squared minus 3Q plus 12.
And you can have another point for that, ma'am. Okay, that is number 9. Again, these are the super duper old ones from 10.2 to 10.6. Okay, and now number 10. That's it. Oh, is that it? Two things that multiply to give me 12. 6 and 2, 4 and 3, 1 and... Can we factor this? That's his question. Well, no, plus they don't have the same variable anyway. They would have to both be p's. Whew. You had me. I was with you, Daniel. That's scary. Number 10. How many terms are there? So what are we going to do? We are going to do, if there's a GCF, we would do it first. We are going to do grouping. Can someone explain what I should pull out of this? You did negative 2x. And then with the other one, you didn't pull out a negative at all. You can totally do it that way. You're going to have a slight sign difference from us, but your answer is still correct. And you can have a point for that. I'm just going to pull out a 2x. And you're left with a 5x minus 7. Y. Thank you, Daniel. You'll have another point for that. So 5x minus 7y. And then with the other term, I pull out a negative 3. So again, I have a 5x minus 7y. And I'm happy because those two sets of parentheses match. So my final answer is 2x. Go ahead, Nick.
2x minus 5xy, or 5x minus 7.
Okay, Nick, get a point for that. Okay, so I'm assuming you had, did you have negative 2x plus 3? And then 5x minus 7y? That's still correct. It's still correct. If you're questioning your sanity at this point, how could you check yourself to make sure you match the original? Ellie, get a point. You could FOIL it out and see if it matched the original. Okay, are there any questions about these math workshops? Are we ever going to solve? Well, yeah, but factoring is just, until we actually know what to do once we factor, it's just like, oh, okay, I factored. That's nice. What do you want me to do with it? So until we get to that point, it just all seems like in vain. But it's okay. Today is probably, I always say this, but for real, this is one of my favorite sections. So the rest of Chapter 3 involves a term called a matrix. And no, not like the Matrix movie. And before I forget, because I forgot to tell first period, do you remember how we had a perfect squares test last 9 weeks? Yeah. Oh, well, near the end of this 9 weeks, we're going to have a perfect cubes test. At the very end of the packet, it shows you your cubes. Perfect cubes. Like 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. Yep, these are things you're supposed to know. So if you're wanting to go ahead and memorize that, that would be wise. However, I would highly recommend you don't memorize like it's 1, 8, 27, 64 because we changed the order on the test. You actually need to know 2 cubed is 8. That way if 2 cubed is 8 is the last problem, you'll get it right. Don't worry, I'll keep reminding you about that and we'll start going over it. I just wanted to give you a big old heads up because you remember how some of our perfect squares tests went. Some of them were really good and some of them were not so good. Okay, so today we're starting to talk about matrices, which are pretty much the coolest things ever. And you're not going to hurt my feelings if you don't raise your hand, so don't feel peer pressure to raise your hand. Who in here just really, really loved the 3 equations with the 3 unknowns? Like it was the best thing ever. Okay. Who in here even loved more than that? They loved the challenge problems. The 4 equations with the 4 unknowns, the 5 equations with the 5 unknowns. They just thought that was the best. Okay, well for those of us who I agree, I enjoy a challenge. However, for those of us who were like, my God, there must be a better, faster, shorter way, there is. I'm so sorry to tell you. Matrices are going to come save the day. We're going to learn how to do matrices in our handy-dandy calculator. And you'll never actually have to, by hand, solve a 4-equation, 4 unknown problem again. Well, you might have to if the teacher asks to show your work. But from here on out, Kylan's going to know how to check herself using this once we get there. We gotta get to the basics of what this bad boy is. But just know that in the end, matrices are going to save the day. Okay, so a matrix, the first one was matrix. A matrix is a rectangular array of variables or constants, and it's in horizontal rows and vertical columns, usually enclosed in brackets. So a matrix is normally in brackets like the one below. Now, sometimes teachers like you get lazy, and sometimes they might leave off the brackets. Or sometimes they might be really weird and use parentheses. But anytime you see a bunch of numbers stacked in this way with rows and columns, it is a matrix. Okay, so the whole point of a matrix is that it can store a bunch of data at once. It can store a bunch of points at once. So it's supposed to make your life easier because it's a good storage system. And we're going to learn that we love them. And if you really enjoy what we do with matrices, there's a lot of math classes in college I can recommend for you because we go matrix crazy in some college math classes because they are the best. But like matrices in real life, so I do have a cool example of matrices in real life. So I love Netflix. Like I know why we have cable because my husband loves sports, but like I could live without cable. I love me some Netflix. So I just finished this show and I was really sad. I'm always sad when I get to the end. And I was like, what am I going to watch next? And then, you know how Netflix has the recommended stuff. They're like, because you like this, there's a 98% match that you will like this, and an 82% match you will like this. And you're like, Netflix, how do you know me so well? Because I clicked on one of the next ones. I'm like, I'm already in love with this new show. So how do you know me so well, Netflix? What are you doing? Like, are you creeping on me and watching me through a video camera to see when I smile? That's how my brain works, but that's not actually what's happening. They're using math. They're using matrices. It's a little more complicated than what we're going to do, but they're using matrices to make those recommendations. So based off of what Angel likes, they know what to input in their matrix, so they know what to recommend to her. And her recommendations are different than mine. And no one at Netflix is actually staring at you. Again, it's all computer stuff, matrices, figuring out what to recommend next. I just think that's the coolest. So if you're wondering when in real life you use matrices, Netflix uses them all the time. Okay, so back to what we need to know, because that's just an aside of why I like them. Is 261 a row, or is 27912 a row?
27.
Woo! A row goes this way. This is a row.
Oh, never mind, that was a column.
And I get real confused, because I don't know. Vertical, horizontal has always been a problem for me. So when you're thinking of a column, I think of things that hold up a building. This direction, the 261, like this, that's not going to actually hold up a building. We need it to go straight up and down to support our roof. So when you think of a column, think of the Greeks and how they had to hold up the building. It needs to be straight up and down, not the horizontal ones. Okay, so we do actually have to know the difference between a row and a column. And each spot has a certain number, which we'll talk about in a second. So each value, like that 2, is called an element. And then another thing that's really cool about matrices is they are so special. So anytime you've seen a variable in any other problem you've been working, it tends to be lowercase. Until now, like X was lowercase, Y was lowercase, everything was lowercase. Matrices are so special, they're the uppercase letters. Like this matrix is represented by the uppercase letter A. If you've been wondering why we've been saving those uppercases, this is why. They go with matrices. So what we want to do first, our first learning target says we need to state the dimensions of a matrix. So if Tylen's wanting to describe her matrix, she's not just going to start spouting off numbers like 261, 715, 930. We're just going to look at her like she's crazy. We need to say stuff like, I have a 3x3 matrix, a 4x2. We want to describe the size of the matrix. So when we're stating the dimensions, which is what we're going to do below, we're really talking about the size. How big is it? So when you describe it to someone, they automatically understand how many rows and how many columns. And literally it has to be rows by columns. O-L-U-M-N-S. And if you're like me and you try to flip things around, so 4x3 means 4 rows, 3 columns. 3x4 means 3 rows, 4 columns. So you've got to be careful. 4x3, 3x4 don't mean the same thing. They represent a different number of rows and a different number of columns. So there's some danger. Bless you. There's some danger that could lie ahead. So in our example above, it has how many rows? And how many rows? The top one. It had 4. Oh, page is already on number 10. I know why. How many columns? Okay, so we're going to call it a 4x3. So this is a 4x3 matrix. So our very top thing, the A equals whatever, is a 4x3 matrix because it has 4 rows and 3 columns. So seriously, the first 6 problems we're going to tackle today, all we've got to do is say 1x3, 3x2. We've got to state the dimensions of the matrix. So that way Paige knows how big it is. So I feel like everyone can do this, so let's just go around. Let's give each group a chance. Table 1, do you want number 10?
3 by 2.
How many rows? How many columns? Okay, you can have a point. Okay, let's, table 2, do you want number 11? That one's hard. Don't overthink it.
1 by
3 by 1.
3 rows, 1 column, 3 by 1. Perfect, you can have a point. Table 3 will let you have number 12. It is 4 rows, 3 columns, so 4 by 3. Number 13, table 4. It is a 3 by 3. We're going to come back to 13 in just a second. It's my favorite one. Table 5, you want 14?
2 by 5.
And then back to you, table 1. Do you want 15?
3 by 2.
And you can have a point. If you didn't add a point for that, you should have, as your group answered, or whatever. Okay, so my favorite one that I want to mention, because I literally could just go on and on about matrices all day. I just love them so much. They're just so awesome. One thing I want to mention is that this one has the same number of rows and the same number of columns. Number 13, it's a 3 by 3. That's going to end up being our favorite kind when the rows and columns match. We actually have a name for that kind of matrix because it does look like a square, so it's called a square matrix. And we're going to find out square matrices are the most useful when we're trying to, like, do stuff with matrices. Eventually we're going to get to inverses and that kind of thing, and it needs to be square. So this is as deep as it gets in Algebra 2 with trig, but we're thinking, like, trying to do well in the ACT, and there might be a matrix question on the ACT. So let's talk about what I would think. I don't think they would ask you to say what size it is, because they're going to have 4 by 3 and 3 by 4 both as an option. It's not really a difficult question. So they got to step up the level of this question. So instead, they're probably going to ask you about one of the things inside, one of the elements inside, like maybe this spot. And they'll say, like, 3 is in what position? So they might ask about the position. And literally it's still the same, it's still just as easy. It is on the 3rd row, 2nd column, so it is in the 3-2 spot because it's on the 3rd row in the 2nd column, so it's in the 3-2 spot. But that's more like a question I would anticipate because it requires a little more thinking than necessarily it's a 4 by 3. So if they ask about the 1-1 entry, you know that's the number 2. If they ask about the 1-2 entry, you know that's the number 6. And so they might ask about, like, who is in what spots. I feel like that would be a better, more difficult question. Just an extra 2 cents today. Okay, so let's go down to number 16 through 19. So our second learning target says I can solve equations involving matrices. So basically, we've been struggle busing to solve really complicated equations that could be put into matrix form, and then our life suddenly gets so much easier. Because with matrices, it's like the birds and the bees come out and life is perfect again because they work exactly like you want them to. In that, literally, since 2x and 5 are the first thing you see in that matrix, they should be equal. 3 and 3y are going to be equal. 3x, 3z, and 9 are going to be equal. It's exactly what you think. The first entry is equal to the other first entry. Second entry, second entry. Third, third. Life is so beautiful. If only all of math would work this nicely. So in that one, I could easily quickly solve for each variable. I have 2x equal to 5. So x equals 5 over 2. I have 3 equal to 3y. So y equals 1 or 1 equals y. Either way, same thing. And I have 3z equal to 9, so z equals 3. Look how much less we have to write. Look how much faster life just became. Thank God for matrices. Life is so much faster. So again, miracles work out, and the first entry goes with the other first entry, second entry, second, third, third, all because of that equal sign telling you that it's supposed to match. Okay, someone last period asked me at this point, they said, so seriously, this is the answer? And yes, it is. And just like any good math student, you could plug it back in and check. For instance, if we plugged in y is 1, 3 times 1 is 3, well then 3 really does match 3. 3 times 3 is 9, so 9 really does match 9. You can plug it back in and check if you would like to. Okay, let's go to 17. I want to know the value of x. You can have a point. Dang. Did you go, Bartow? Who said it first? Thank you, Nick. Nick, you can have the point. Thank you, Daniel, for being honest. Okay, and then y is what? And Paige had it out first, Daniel. Sorry. Paige, you get a point. Okay, are there any questions on 17? Then let's go to 18. And don't overthink it. Seriously, still just set the top equal to the top. Tell me what you get for x. It is 5. Is your point? Okay, so number 18, you're supposed to set 4x equal to 15 plus x. I subtract x from both sides. I have 3x equals 15, so x equals 5. What am I supposed to get for y? Who said 3? No, that's correct. 5 equals 2y minus 1, so 6 equals 2y, so y equals 3. That's correct, Josh. It's 3. Okay, are there any questions on 18? Now, I get you're annoyed that they had 2 variables, like on that top line, had both x's, but they're the same variable, so that's fine. Just solve like an equation. We're really just using a matrix to store multiple equations at this point. Okay, number 19 is our only complicated looking one. Why does it look complicated? Yes. So, I'm supposed to set 4x minus 3 equal to what? 9. Yes, literally set it equal to 9 and solve. Tell me what you get. Yes, I get 4x equals 12, but then does x equal? Okay. I don't know who to give the point to, so I'm going to save it in. What does y equal? Nick, yes, get the point. So 3y equals negative 15. So y equals negative 5 for that second entry. And then for that third entry, I'm supposed to, why do I not have to do anything? 7 equals 7. We don't have a variable to solve for. And then we know that was supposed to happen. And then what am I supposed to get for z? You can get a point. 13 equals 2z plus 1. 12 equals 2z. 6 equals z. Now, showing work always helps, especially when the math teacher's grading your stuff. I get that. But if you're able to do these in your head, you really don't have to show anything. Okay, and again, if you want to plug these back in, you can. If I plug in 3, 12 minus 3 is 9. 9 equals 9. That's right. Negative 15 equals negative 15. 13 equals 12 plus 1 is 13. You can plug it back in and check. Okay, are there any questions about this? Okay, then flip to the next page. Yes. So here are the nice words I'm going to say. I'm going to save operations with matrices till tomorrow, and I'm going to have a video of me going over this. Although, really, you don't even need me, because when you add or subtract matrices, life works out exactly like you want it to. Seriously, Jax is going to add the top left entry 6 with the other top left entry negative 4. He'll add the 6 and the negative 4 together. Then he'll go to the negative 5 and the 3. It goes exactly in order, just like, I don't know, it's beautiful. It does exactly what you want it to do. The only thing that gets complicated with matrices is multiplication, and that's not an operation we're handling today. And it's really not that hard either. Matrices are the best. Okay, so I'm going to go over these notes tomorrow, but flip to the next page. In addition, Angel needs to not only take notes tomorrow, she also needs to get through this worksheet on the next page, page 3. So maybe she wants to get a bit of a head start on that tonight, that's fine, or if she wants to stay up till tomorrow, that's fine too. She's that good and that fast, she can get it done. No, just the front. Good question. No, just the front. Okay, so there are 20 problems, and we're going to cross off one of them. Which problem do you think we're going to cross off? Go look through all of them. Look through it. There's one that's got 2 variables that's going to be a little. 18 we're not mad at.
No, 18 we're not mad at.
20. Who said it? Jax gets the point. We're mad at 20 because it's got x's and y's on the same line. So literally I have x equal to 4y. Now, yeah, that's been stolen. You're so late. I'm going to put skip next to it for now. We'll wait for me to come back and fix that one. But Nick is smart. Nick understands substitution. So if x equals 4y, everywhere in the second line you had an x, plug in 4y.
Oh, wow, yeah.
Like, it's not hard. It's just going to require substitution. Okay, so tomorrow Nick has 19 problems and some notes to get done. And if you think on Thursday I'm not going to check to make sure that Talon has the worksheet done and the notes done, I am. So if you're done with your test today and you would like to go ahead and work on that worksheet, my gosh, Talon can knock out the top 6 where you state the dimensions in 2 seconds. Okay, are there any questions about this stuff?